Last time we talked about rational equations and how to solve them. In this video, we're going to take those same techniques and then work on some more difficult rational equations. Alright, so let's go ahead and solve this equation. Alright, and if you remember from last time, our basic strategy was to figure out some number that we could multiply by so that we could get rid of the fractions and end up with a really simple equation to solve. We're going to do that same thing here. But you'll notice this time we have different denominators. Right? And so it's not so easy to figure out what to multiply by. So what we're going to do is first get a common denominator. Right? So we know how to do this. So let's get a common denominator by factoring our denominators first. So 8 is the same thing as 2 times 2 times 2. And then over here we have 2 times x. Right? Let's go ahead and get a common denominator. So for the fraction on the left, it looks like I need a factor of x. Right? And then here on the right side, well, let's see, what's missing over here? It looks like we're missing 2 factors of 2. Right? So now, if you notice, the denominators are the same. So we end up with x over 8x equals 12 over 8x. And now that I have the same denominator, it should be really easy to see what's going to happen next. If I multiply both sides by 8x, what will happen? Right here, 8x divided by 8x, that is 1. Right? So this is just x. And then over here, again, same thing. 8x divided by 8x, that is 1. So we just have 1 times 12 is 12. And then we end up with our answer. Alright, so, and also I want you to remember, what does this answer mean? Right? 12 is our solution, which means that if we were to plug that back into our original equation, that would make this equation true. Alright, let's look at another one. And then the third one you're going to do on your own. Okay, so again, remember, we're going to try to multiply by something so that we get rid of our fractions, so that we have a real simple equation to solve. In order to do that, let's go ahead and get a common denominator. Alright, so let's factor our denominators. So this is 1 over 2 times 2 minus 5 over 2 times 3 times x equals 2 over 3 times x. Alright, so let's take a look and try to get all three of these denominators to be the same. What factors am I missing over here? Looks like I'm missing a 3 and an x. Alright, for this one in the middle, it looks like I'm missing a 2. So let's multiply by 2 over 2. Okay, and then for this last one, I'm missing 2 factors of 2. So that would give me 3x over 12 minus 10 over, 12x equals 8 over 12x. Alright, and a lot of times what will be easier is you can combine these two fractions now here. Alright, so let's make that 3x minus 10 over 12x equals 8 over 12x. Alright, so now hopefully you can see what we need to do, right? We're going to multiply both sides by 12x. And let's make that 12x over 1. Why do we do that? So that here, 12x divided by 12x, that divides and becomes 1. So we end up with 3x minus 10 equals, and then same thing over here, 12x divided by 12x, that becomes 1. So we end up with 8. And now we have a real simple equation to solve. Right? Let's add 10 to both sides. So we get 3x equals 18. And then if I divide both sides by 3, we end up with x is equal to 6. And there's our answer. Alright, you're going to do this one on your own. So please pause, do it on your own, and then come back to check. Alright, so you should have your answer. Let's have you check now. Okay, so let's get a common denominator, and we're going to start by factoring. So this is 7 over 5 times 2 times x minus 1 over 7 times 2 equals 1 over 5x. Right, let's get a common denominator. So what's missing? For this first fraction, looks like I'm missing 7. So let's multiply by 7 over 7. For the middle one, we're going to multiply by 5x over 5x. This one I'm going to multiply by a 2 and a 7. So now I have 49 over 10x minus 5x, not 10x, I messed up there. This is going to be 70x, sorry. So 5x over 70x equals 14 over 70x. Okay, and on the left here I can rewrite this as 49 minus 5x over 70x equals 14 over 70x. And right here, next thing we can do is multiply both sides by 70x over 1. So that those denominators will divide out, and we'll end up with 49 minus 5x equals 14. Almost done here. Let's subtract 49 from both sides. We have negative 5x equals negative 35. And then if I divide both sides by negative 5, we'll end up with x equals 7. Hopefully you got that right. Okay, we're going to do two more, and these are going to have a little bit more complicated denominators to work with. Okay, but we're going to apply the same technique. In order to figure out what to multiply by, we're going to try to get a common denominator. So let's first factor these denominators. Right, this one we could factor using difference of squares. So this will end up being x plus 2 over x minus 5 times x plus 5. The second one, this will end up being x times x plus 5. Right, we factor out an x. Right, and then the last one, right, again we can take out a greatest common factor of x. So we have x times x minus 5. Okay, so always factor your denominators. All right, now let's get a common denominator. Let's figure out what factors we are going to need. Let's zoom out a little bit. All right, so for this first fraction, it looks like I'm going to be missing a factor of x. So multiply by x over x. For the middle fraction, I'm missing a factor of x minus 5. So let's multiply by x minus 5 over x minus 5. And then for the third one, let's multiply by x plus 5 over x plus 5. All right, so let's go ahead and multiply this. So this would give me x squared plus 2x over x times x minus 5 times x plus 5 plus 6x minus 30 over x times x plus 5 times x minus 5 equals 2x plus 10 over x times x minus 5 times x plus 5. All right, so now that we have the same denominator, we can combine these two here over on the left. So this will be x squared plus 8x minus 30 over all of this, x times x plus 5 times x minus 5. All right, so even though it's a little bit more complicated, it's the same idea. Okay, so now we're going to multiply by x times x plus 5 times x minus 5 over 1 on the left and again on the right. So that these will divide out, right? This whole thing divided by this whole thing is 1. So we just end up with x squared plus 8x minus 30 equals, same thing happens over here, just we get 2x plus 10. All right, so now this time we don't have any more fractions, but it's a little bit more complicated of a problem because it's quadratic. All right, so if you remember when we work with quadratic equations, our strategy is that we want to get one side of the equation equal to 0. So let's go ahead and do that. Right? Let's subtract 2x from both sides. That would give me x squared plus 6x minus 30 equals 10. And then if I subtract 10 from both sides, I end up with x squared plus 6x minus 40 is equal to 0. Right? And then we have a pretty basic quadratic equation that we've worked with many times before. Right? So to solve something like this, there's multiple techniques that we can use. This one we can actually factor. Right, so we can use our magic x technique. For the sake of time for this video, I'm not going to show all that. You should know how to do that. But if you apply your magic x, you should get two factors here, x plus 10 times x minus 4. Right? And if these two multiply to get 0, then we can conclude that either x plus 10 is equal to 0, or x minus 4 is equal to 0. And we'll solve these two, and we end up with x is equal to negative 10, or x is equal to 4. Right? So there's two possible solutions. X could either be negative 10, or it could be 4. All right, for our last one, I would like you to try this one on your own. And one thing I want to caution you, notice that you have a subtraction here. Okay, that sometimes throws people off. All right, so go ahead and do this one on your own. Same strategy, and then please check back at the end because there's something important at the end I want to show you. All right, go ahead and pause and do that. Welcome back. Hopefully you were successful with this. Let's see the answer. So if we factor our denominators, we would have x minus 5 times x plus 2 here. And actually that's the only factor that I need to, the only denominator I need to factor. Okay, let's get a common denominator. And it turns out that this one is complete already. The second one, let's multiply by x plus 2 over x plus 2. And the third one, let's multiply by x minus 5 over x minus 5. Right, we're going to end up with 21 over x minus 5 times x plus 2 minus 3x plus 6 over x minus 5 x plus 2 equals x squared minus 5x over x plus 2 x minus 5. Okay, so again, now that we have a common denominator, we're in good shape. Right? I'm going to go ahead and do the subtraction here. Okay? All right, so this is going to end up being 21 minus 3x minus 6. Okay, so don't forget that. Right? We're subtracting this whole thing, right? So minus the 3x and minus the 6 over x minus 5 times x plus 2 equals x squared minus 5x over x plus 2 x minus 5. Okay, now that we have our common denominator, let's go ahead and multiply by x minus 5 x plus 2 over 1 to both sides. All right, and we do that so that, again, this will divide out. All right, so we end up with 21 minus 3x minus 6. Oh, and I could have actually combined those, but I'll do that next. Equals x squared minus 5x. Okay, so on the left here, let's simplify that. This is negative 3x plus 15. All right, hard part's over. Now we just have a simple quadratic equation to solve. So let's get 0 on the left-hand side. Let's add 3x to both sides. We have 15 equals x squared minus 2x. And then if I subtract 15 from both sides, we'll have 0 equals x squared minus 2x minus 15. All right, so again, we have a quadratic equation here that you should know how to solve. This one can be factored. I'm not going to show the work of the magic x, but you should know how to do that. You'll have x minus 5 times x plus 3. Right, now, if I set these two factors equal to 0, so x minus 5 could be equal to 0, or x plus 3 could be equal to 0. And we'll end up with x equals 5, or x equals negative 3. Now, did you get those two answers? Okay, here's the important thing I need to show you. It turns out that actually both of these are not solutions. Right, even though we got two answers here, both of these are not solutions. Right, remember, a solution has to make the original equation true. Right, and if we go back to the beginning, right, we're way back to the beginning, right, we got to think, would both of these make this original equation true? And it turns out that 5 here will not make that equation true. Why is that? Right, the reason is because right here, we would have a denominator of 5 minus 5, which is 0. And when you have a 0 in your denominator, this fraction becomes undefined. Right? So this would make this fraction here undefined. Right? It actually would also make the first fraction undefined, right? Because right here, 5 minus 5 is 0. Right? So we'd have a 0 in this denominator. Right? So 5 would make those fractions undefined. So therefore, 5 cannot be a part of the solutions. right? That is what we call an extraneous solution, right? So that is not part of our solution. So the only answer that works is -3.